Yes, class. Am I audible to all of you? So in the last class, we had stopped at the application of Pascal's law. That was hydraulic lift. So hydraulic lift we discussed, that was basically a small force is applied and a greater force or a greater pressure is being sent. So small force will lead to greater result. So how do you modify that? Using the concept of area. Just use the concept of area. Okay. So F1 by A1 is equal to F2 by A2. This is the entire concept that we'll be using. So question we didn't see. Let's see this question then. This question says that in car lift, compressed air exerts a force F1 on small piston having a radius of 5 centimeters. This pressure is transmitted to a second piston of radius 15 centimeters. All right. So if mass of car to be lifted is 1350 kg, what is F1? What is the pressure necessary to accomplish this task? This is the question. See, F1 into A1, or leave F1 right now. Just talking about the area. A1 will be pi r square. That's how you calculate the radius, right? So pi r square, radius is 5 centimeters. So this becomes 5 into 10 to the power minus 2 whole square, pi r square. All right. When we're talking about force F2, F1 we don't know. F1 is missing, that we have to calculate. When we're talking about F2, F2 is equal to mg. Mass is given as 1350 kg. Acceleration due to gravity is 10. So this becomes 13,135,00 Newton. So when we are required to calculate, what is the formula that I have told you? F1 by A1 is equal to F2 by A2. So F1 is equal to F2 by A2 into A. So F2 is 13,500. Area 2. Okay, see, A2 is pi r square again, but radius is 15 centimeter. So area is pi 15 into 10 to the power minus 2 whole square into pi 5 into 10 to the power minus 2 whole square. Pi will be cancelled, 10 to the power minus 4, 10 to the power minus 4 will be cancelled. So just check whatever answer you will get the answer as multiplied to 25 into 15 into 15, this much. Just solve it, cross check, let me know whatever is your answer. Write this down, write down this question. It's pressure is here. I'll shift it a bit. See, buoyant force, what is meant by buoyant force? See, if I take a container, suppose, let me draw it. I have taken a container and I have completely filled it with water. Okay. Now, I am putting a very light weighted box in this. All right, within this, I am putting this. Even if you'll take the real life example in bucket, if you're putting mug inside the bucket filled with water, you feel a resistance to the bucket. You're not easily able to put it back into it, right? There's a resistance that you feel when you're putting the mug into the bucket, which is filled with water. So there's a resistance or there's an upward force that is pushing the object back to the surface. You are applying the force downwards. Gravitational force is acting downwards, but there's an upward force which is acting from the liquid. This force acts from the liquid. This force is known as buoyant force. And this entire phenomena of throwing the body up back is called as buoyancy. Okay. So what is meant by buoyancy? It's written also the upward force acting on a body partially or wholly immersed in a fluid is called buoyant force. It is also known as upthrust or buoyancy. Suppose this is the box I have taken. This is the water. I am putting it back. So here downwards mg will be acting. That is the weight of the liquid will be acting. But upwards a buoyant force will be acting. This entire concept is known as buoyant force. Now, an extension of buoyant force which is known as Archimedes principle. Archimedes principle basically says that, see, if some amount of liquid is being displaced, this is the container. This is the water. See, can you notice this? Only this portion is present within the water. Right? Only this small portion is present within the water. The rest of the surface is above it. Right? The rest of the surface is above it. So only a small portion is within the water. So amount of water that is being displaced by the body is actually the buoyant force, right? If the body is completely or wholly partially immersed, however it is immersed, how will the body go inside the liquid? When the liquid will shift and the body will come down. If I have to accommodate this, what do I have to do? I have to make this much space. If this much amount of block is coming inside, this is outside. But if this much amount of block is coming inside, so I have to make this much space for it, right? So if this much of space is made by the body, so where will the liquid go? Liquid will be displaced. So this is exactly what is meant by Archimedes principle. When a body is wholly, means completely, or partially immersed in a liquid, buoyant force acting on the body is equal to the liquid displaced, volume of the liquid displaced. It means, let's say FB is the buoyant force acting, rho is the density of body, downwards mg weight is acting. So buoyant force is basically mass of volume. How will we write? Mass, what is buoyant force equal to? Can you look at the diagram? Buoyant force is balancing mg. That is, m is what? M is mass of liquid displaced into g. FB, because you know FB is equal to mg from the figure. This upward force is balancing the downward force. Upward force is balancing the downward force. So FB is equal to mass of the liquid displaced into acceleration due to gravity. Now, further we can say, how can we write mass? You know, density is equal to mass by volume, correct? So from there, what is mass equal to? Density into volume, right? So what is the density? Density of liquid, because we are talking about the mass of liquid displaced. So how will we consider the density of the body? We have to consider the density of the liquid itself. So this is density of liquid into volume of liquid into G. So basically, what is the density of liquid? What is the volume is V? Density of liquid is sigma. G is acceleration due to gravity. Why are we not taking rho? Because rho is the density of the body. We have to consider density of the liquid that is being displaced. This is what is meant by Archimedes' principle. See, the statement is written. This is about apparent weight that I'll tell you. First, tell me, concept of Archimedes' principle is clear to all of you. Khadija, Leena, Hudeja, Mariam, Nuha. Is it clear? Do you want to ask anything?
Yes, ma'am.
Clear? Other students also?
Yes, ma'am.
Yes, ma'am.
Write it down. Now, the concept of apparent weight. What is the concept of apparent weight? See, if I take a body in air, suppose I have this in air, so it has a certain weight. Now, when I'll dip it in water, I'll feel this is a little light. I'll feel it is lighter in comparison with what? Air's weight. Right. So there's a difference in the weight. There's a decrease in the weight. So basically, this is the apparent weight, because that is not the true weight. So you say this is the apparent weight. So what exactly is apparent weight? Take the weight in air, take the weight in the liquid, that is the water, whatever is medium. That difference will give you the apparent weight. Yes, so if body is fully immersed, apparent weight is basically weight of the body minus the buoyant force that is occurring. Okay, this is the difference that will arise. So what is the buoyant force? What is the weight? Weight is V rho g, because weight involves weight of body, and buoyant force I have just told you, that is V sigma g. So from here, if we take V rho g common, we'll be left with 1 minus sigma by rho. Correct. So what is V rho g? V rho g was the weight in air. So apparent weight will be weight in air. This is weight in air, 1 minus sigma by rho. What is sigma? Sigma is the density of liquid. What is rho? This is the density of the body. So there's a difference between these two, liquid and the body. This is the weight in air. This is the concept of apparent weight. Now, with the concept of apparent weight, how will you identify a body sinking, floating, or what is happening to the body? There are two things. One is the liquid which is present, fluid. One is the body. Now, both will be having their own densities. So when the density of the body exceeds the density of liquid, we say the body will sink, because body is heavier. Mass of the body is more, greater. Body will sink. If vice versa occurs, that is, density of liquid becomes heavier than the density of body will move upwards. Body density is greater, it will move downwards. When density of the liquid is greater, it will move upwards. Fine. If both are same, body will float. At the surface, body will float. Now, what was the definition? Some points here. Apparent weight of an immersed body is equal to the difference between the weight of the body in air and the buoyant force. Volume of the immersed part of the body determines the magnitude of buoyant force. How much will be inside within the liquid will determine how much buoyant force will be acting. Magnitude of buoyant force depends on density of the liquid, volume of the immersed part, and not the shape or composition. Okay, write it down from here, start writing, then we'll practice some questions. this question says the density of ice is 917 kg per meter cube. What fraction of ice lies below the water? Density of seawater is 1024 kg per meter cube. What fraction of iceberg do we see, assuming it to be as having the same density as that of ice? Fine. See, basically this says that this portion is above water, that is V dash. Volume which is below is this. And total volume is V. So the volume that of ice, see this part is there. This is present beneath the water, which is V minus V dash. See, total volume is V. Above portion which is coming, the above portion which is coming outside, above is V dash. So how much of ice will be left within? Understood? You are asked to calculate the fraction of ice. So for fraction, you should know the amount that is present above and present below. Okay. So here, basically, you will say weight is being balanced. Correct. What is the weight? Weight is equal to the buoyant force. We'll say simply we will use the fact that weight is equal to buoyant force according to which principle? Archimedes principle. Clear? So how do we write the weight of the object? Volume is V. See, weight means mg. Mass means density. So what is the density? Rho, density of body, into mass means density into volume into g. So this part is equal to V rho g. FB, this FB, that is the buoyant force, is equal to volume of body immersed into the liquid. How much is immersed? V minus V dash, not V or V dash. V minus V dash. Sigma. GG will be cancelled. So you are left with, exactly we are left with C. V minus V dash by V is equal to V into density is 917. This is equal to V minus V dash, let's keep it like this, is equal to density is 1024. So from here, if I bring this V into the denominator and this 1024 here into this denominator, so I'll be left with 917 by 1024. I've just interchanged the terms. Understood? I've just interchanged the terms. From here, V by V minus V dash by V is also equal to 917 by 1024. That means 1 minus V dash by V is equal to 917 by 1024. Clear? This is it. Now I just have to simplify it. I want V dash by V. So what is V dash by V? I'll just shift the 1 over that side. 1 minus 917 by 1024. Understood? So when the percentage is calculated, multiply V dash by V into 100. That is this entire term. 1 minus 917 by 1024 into 100. Whatever percentage will come, that will be the answer. This is how you have to calculate. Write it down. A tank contains water and mercury as shown in the figure. An iron cube of edge 6 centimeters is as shown. What is the fraction of cube inside the mercury? This saying iron's density is given, mercury's density is given. So both are separated. See, this figure is already given. This is given. See, block is given. On the block, buoyant force is acting upwards. The weight is acting downwards. And the entire length is 6 centimeters. So portion of X we have assumed to be in water. So how much will be left if total of this is 6 and X has been taken. So this will be 6 minus X. So this will be X. This is 6 minus X. Now this time weight is being balanced by buoyant force of water as well as buoyant force of mercury. Both the buoyant forces are there. Buoyant force of water plus the buoyant force of mercury. So if two liquids, what is the main purpose of this question? That if more than a single liquid is given to you or more than a single fluid is given to you have to consider their individual buoyant forces which will be acting on the system. What will be the difference? See, weight will be the same, rho Vg, density of body, volume of body, acceleration due to gravity. There's a difference between rho and sigma. Rho is the density of the body, which is kept into the fluid. Sigma is the density of the liquid into which the body is being kept. So weight will be V sigma G, density will be of water, plus V sigma G, density will be that of mercury. So from here, if we take area for volume, see acceleration due to gravity will be cancelled from everywhere. Density, air volume can be written as area into thickness. So for the total cube, we will write thickness as 6. So volume is done, density is rho. Volume for water. See, for water it will be area into what is the thickness for water? X. Density of water plus. Again, area into thickness X, 6 minus X and density of mercury. So area will be cancelled. So this will be 6 into 10 to the power minus 2 because this was in centimeters. So 6 into 10 to the power minus 2. Density. Density is 7.7 into 10 to the power 3 is equal to X. We don't know that we have to calculate. But density of water is 1000. So this will be 1000 X plus 6 minus X into 13.6 into how much is given? 13.6 into 10 to the power 3. From here, you have to calculate X. When you will calculate, most probably your X will come out to be 2.8 into 10 to the power minus 2 meter. Like this, you have to calculate. So we have just substituted the value. Main equation was this. Buoyant force from the water as well as from the mercury. Write it down. Now, before we start with surface tension, you have to understand two types of forces which exist in your system. So when there's a force of attraction between molecules which are made up of the same substance, we say that the force between them is force of cohesion. So cohesion or cohesive forces are for same substances. If forces of attraction between two different molecules are made, then we say these are forces of adhesion. So these are the adhesive forces and between different substances. Now, in some cases, forces of cohesion would be greater than forces of adhesion. In some cases, forces of adhesion is greater than forces of cohesion. So how will you determine which force is greater? So I'll give you an example. In this example, I have taken a glass of water. You suppose you have taken a glass of water. Now, when you invert the glass, water falls down. So what happens? All the water droplets are vanished, or you think there are some droplets left in the glass? What do you think? When if you have taken a glass completely filled with water, you've inverted it upside down. Water has fallen. Do you think the entire will be fallen off or something will be left? Something will be left. Some droplets will be left. Very good, Khadija. Reason is that, see, there are forces which are existing between all. When water was present, so between the water molecules, same substance, water molecules, so forces of cohesion were present. But between the, suppose, let's say this is made up of steel. This is a steel glass. So between steel and water, which force is existing? Force of adhesion is existing. So in this case, force of adhesion is greater than force of cohesion. It's stronger than forces of cohesion. So that's why water molecule is going off. But since this bond is stronger than the cohesive forces, than between water, the bond between water and steel is so strong that it does not allow this bond formation. Rather, it allows this bond formation. But if I'll give you one more example. If I have taken the same glass, same thing I have taken, it's just that I have filled it with mercury. And now I have inverted it. If I have taken the same glass and I have now inverted, and it was having mercury initially. When you will empty it, now you will see none, not even a single droplet of mercury is left. Reason is that the force that was formed between the mercury and the steel glass, that is the force of adhesion, and between the mercury molecules which are falling together, this is the force of cohesion. So here the force of cohesion is stronger than force of adhesion. That's why all the mercury molecules are pulling each other and coming down, and this bond formation cannot exist. This is forming very quickly. This is the reason. So these are the two types of forces which you should know, and these terms will be repeated. That's why we are studying this. Write down this: intermolecular forces, classification of intermolecular forces. If you've completed, you can start leaving one by one. Okay, in the next class, I'll continue this. Now you have the class of thermal physics. Thank you so much.